Hey guys, Mr. Martin with a video on linearization or tangent line approximation. A tangent line approximation is when we use the tangent line at a particular point to estimate y values for a function. So the way it goes is that imagine this is a curve that has a relatively difficult equation. Um, we can use the tangent line to approximate y values really close to that tangent line. So like if we look at the red line, we'll call this value x equals a. All of the y values close to a are almost identical to what's on the green curve. So a tangent line centered at x equals a is a really good way to approximate y values if we have a pretty difficult model. To illustrate this, we're going to find the linearization, again, the same as a tangent line approximation. They are analogous. So to do a linearization, you need the derivative and a point on the line. So derivative, point on the line. So in this case, our a value is x equals 0. So f of 0 is 1. So on the line, we have the point 0, 1. So next, we need the derivative. We can rewrite the square root of x to be 1 plus x to the 1 half. So f prime of x equals 1 half times x plus 1 to the negative 1 half times 1, which if we rewrite is 1 over 2 times 1 plus x to the positive 1 half. So f prime of 0 is 1 half because the square root of 1 is 1 times 2 is 2, so we get 1 half. To put this in the form of f prime of a times x minus a plus f of a, we would have, so in the place of f of x, we're going to have L of x for our linearization. So we're going to have L of x equals, so f prime of a is 1 half times x minus 0 plus f of a was 1, so plus 1. If we simplify this, we get 1 half x plus 1. So our linearization is this. So for part A, to estimate the square root of 1.02, to end up with 1 plus x to be 1.02, it's going to be necessary that x equals 0.02. Basically, the difference between 1.02 and 1. So to approximate the square root of 1.02, we substitute 0.02 in for x here. So L of 0.02 is 1 half times 0.02 plus 1, which equals 1.01. We'll call this part A. Oh, you didn't see any of that. Excuse me. So again, the linearization of 0.02 equals 1 half times 0.02 plus 1, which equals 1.01. So if we calculate the square root of 1.02, we get 1.009, which is basically 1.01. So the exact value is 1.00995. So basically 1.01. So this linearization works out really well, but notice how close 0.02 is to 0. So for part B, let's see. So for part B, we're going to use this same linearization, but in this case, x is the difference between 2 and 1, which is 1. So our linearization at 1 is 1/2 times 1 plus 1, which equals 1.5. So the actual square root of 2 is, oh, turned it off, just a moment. So the actual square root of 2 is 1.414. So the actual square root of 2 is 1.414. The estimation we got was 1.5. Right. So when it says calculate the error, it is so the actual value. So we'll just say actual minus estimated, and we'll put that in absolute value. So the absolute value of 1.414 minus 1.5 equals, that should be 0.086, which it's hard to know how close that is without getting a percent error. So to get percent error, we divide by the actual value and multiply by 100. So 0.86, oh, excuse me, 0.086 divided by 1.414 times 100 is basically like 6.1%, 6.1% error, which isn't terrible, but is probably further off than the 5% error that is standard. For example 2, we're just going to take out part A and jump straight to using x equals 2 to approximate 2.5 for this. So first, again, we need the y value when x is 2. So y of 2 is 2 plus 1 over 2, which is 2.5. The second thing is we need the derivative. So y prime equals the derivative of x is 1. And 1 over x is the same as x to the negative 1, whose derivative is negative 1 over x squared. The slope when x is 2 is 1 minus 1 over 2 squared is 4. So 1 minus a fourth is 3/4. The linearization is, now again, our formula is f prime of a times x minus a plus f of a. So f prime of a is 3/4 x minus 2 plus the y value 2.5. We'll say the same as 5/2. So we get 3/4 x minus 3/2 plus 5/2, which is 3/4 x. That's 2 over 2, so plus 1. So our linearization centered at x equals 2 is 3/4 x plus 1. So to estimate 2.5, we're going to have L of, so we need to just use the difference between 2.5 and 2. So that means our delta x is 0.5. So L of 0.5 equals 3/4 times 1/2 plus 1. So that's 3/8 plus 1. So 1 plus 3 divided by 8 is 1.375. So our estimated value is 1.375. We can go back and calculate the actual value by substituting 2.5 in for x. So 2.5 plus 1 divided by 2.5 is 2.9. That doesn't seem right. To make a mistake. 2.5 plus 1 divided by 2.5. 2.9.